Hello folks, we are again back with the next video. This is for the next problem in the miscellaneous, that is cos y equal to x times cos a plus y. Another important problem has been asked many a times in the board exam. The same thing, as I always tell, can be done in number of ways, but then we'll try to do in a particular way which maybe is easier for you to recollect during the exam time. Same problem, it can be you can find it happening at several other places as we study the textbook. So as I told you, quite important. So let's see now how to go about doing it. What we are going to do over here is we are going to take the x on one side, and we will take these terms, or the other terms on the other side, and then we will try to work like that. So therefore it's like you will have probably you can have 1 by x equal to cos a plus y by cos y. What if we have it like this? Let's see how it happens. So you will have it like, I hope the question is correct, cos y equal to x times cos a plus y, right? X times cos a plus, yeah. So we have got the cos y on this side, so we got 1 by x. Now since we have studied this formula last year, cos a plus b or cos x plus y, let's apply that formula and see how it is useful to us. So therefore this will work out as 1 by x times cos a cos y minus sin a sin y. This is how we had studied the formula last year. So let's apply it that way, now to begin with. So it's like cos a cos y minus sin a sin y. Now let's try, because the common denominator, let's try to apply this. So this will be cos a cos y by cos y minus sin a sin y by cos y. That's all, 1 by x. So what happens here, let's check. The cos y cancels each other. You're getting cos a over here, and this is sin by cos, so that happens to be tan y. So you have got sin a into tan y, and this is what we are working with. You could call it as x raised to minus 1 if you want, or 1 by x as it is. Now we can, since we know after doing all this that it is finally dy by dx that we require. In this problem also they tell us that you have to show that dy by dx is cos squared a plus y by sin a or something like that. So let's see now how to do it. As usual, derivative with respect to x on both sides. So let's check now how that is working. So derivative with respect to x, what will come here? It will be x raised to minus 1. Actually, x raised to minus 1 for us is minus 1 by x squared. So that way this will work to cos a. Derivative of cos a, because a is constant, cos a is also constant, no derivative. So the derivative will be 0. Here, derivative of this term minus sin a is a constant. So you have to find the derivative of tan y. So minus sin a as it is, derivative of tan y we all know is sec squared y, but because we are finding the derivative with respect to x, this will become dy by dx. That's it, our work is over. We have to find dy by dx. Let's get the dy by dx on one side and the other terms on the other side. So this obviously comes to the denominator, minus 1 by x squared by minus sin a into sec squared y. Now the minus can cancel each other. Our question says that we should be getting cos squared a plus y. It's just a matter of bit of a change, that you should be getting cos squared a plus y by sin a. So that's it. Sin a is already there. So let's see how this goes. 1 by x we all know is cos a plus y. We have this, so let's have that substituted. 1 by x, you can take this expression. 1 by x is cos a plus y by cos y. So 1 by x squared is obviously cos squared a plus y by cos squared y by sin a into sec squared y. Now I hope this is clear to us. It has come from this step. We have taken it from this step, because 1 by x is cos a plus y by cos y. So 1 by x squared is going to be the square of it. So cos squared a plus y by sin squared, by cos squared a plus y. Now 1 by sec squared we all know is cos squared. So that way you can have that bit of that manipulation, cos squared a plus y by, or rather, multiplication by a division by a fraction is multiplication by a reciprocal. By that idea, this will come to, it will be cos squared y multiplication by a reciprocal into 1 by sin a into sec squared y. Cos squared y, sec squared y, they are reciprocal ratios. So cos squared y into sec squared y is always going to be 1. So because they are in product form, it will be 1, and your answer will be cos squared a plus y by sin a. And that's it. That's what we have to show. We have to show that dy by dx is cos squared a plus y by sin a. That's how it is. So I hope that is clear to us. We had this from that step. Then we have, because it's division by a fraction, multiplication by a reciprocal, so 1 by, and then terms sine and cos, and that's how you get the answer. That's all. It's quite a simple problem. So maybe we can have the next part here. Yeah, I think we can have the next part also over here, next question also over here, and then we can check out for the other parts later. I think we can have the 17th one. 17th one says that x, 17th one is an easy problem. Why? Because it's a parametric form problem. X equal to a times cos t plus t sin t, and y is a times sin t minus t cos t. Okay, so this is very clear that it's a parametric form, and the question is you have to find d squared y by dx squared. So as usual, we'll find dy by dx, and then from there we will find out d squared y by dx squared. So let's go about doing it. X we'll take separately, we'll take dx by dt. Y we will take separately, get dy by dt. From there, get dy by dx, and then proceed to get d squared y by dx squared. That's going to be our way of working. So let's have this dy, let's have maybe y. So dy by dt, a sin t, derivative of sin is cos, and this is a product. So you'll have t first, derivative of cos t is minus sin t, and